So this section, like I said, is a review of what we have learned in Algebra 1. I don't remember how much of it we remember. I don't know how much of it you guys remember, but it's all about exponents and exponent properties. So we're starting off with the basics of what we've already learned in Algebra 1. We have a bunch of different properties here, okay? A couple of different rules to follow. The first one is the product of a power. So if I have a number or a variable, right, the same base, and I'm multiplying it and they have different exponents, does anyone remember what we do to combine the exponents? Does anyone know what we do to combine the exponents? Not multiply them, because that would be multiplying if we did mn. Add them. It's m plus n. So if I have x to the 5th times x to the 6th, I'm just adding those. I'll get x to the 11th. Ugh. Yeah, okay, so it's coming back to us. How about, this is freshman year. How about a to the m raised to the nth power? What's the relationship? What do I have to do between those two exponents? A times mn, or a to the m times n, right? I multiply them. So if I had 6 to the 3rd power and I raise that to the 4th power, I keep that base of 6 and I'm raising it now to the 12th power, because 3 times 4 gives me that exponent of 12. Okay? The power of a product, I have to take my exponent, and it becomes the exponent on every term, every base that are inside my parentheses. So it would become a to the m, b to the m. Okay? So if I had something like 4x cubed all raised to the 2nd power, first off, that exponent is brought to the 4 and it becomes 4 to the 2nd power. And what do I have to do between the 3 and 2? Multiply it. So that becomes x to the 6th. I can reduce that, or I can simplify it even further, because that 4 has a pretty small exponent, right? 4 squared, or 4 to the 2nd power, is just 16. All right, so 16 x to the 6th would be my final answer on that one. Did I lose you?
Yeah,
to the 6th, because we multiply.
Wait, so are we just taking the 4 and then doing 4 times?
Yeah, when we give that exponent to the 4, it just becomes 4 times 4. Okay. If we have a negative exponent, we want to make it positive somehow. So if we think about bases and numbers as fractions, right? This a to the negative mth power is like saying it's all over 1. Just like if I told you 2 and I told you to put it as a fraction, you'd tell me 2 as a fraction is 2 over 1. To make our power positive, we change the placement of the entire term in the fraction. So in this case, a to the negative mth power is on top of my fraction. I'm going to move it to the bottom of my fraction to make it a positive power. And if I'm moving the entire term, what do I have to put as a placeholder? 1. So a to the negative mth power is the same as saying 1 over a to the mth. And if I had a to the negative mth power, right, or 1 over negative a to the mth power, to make this positive, I'm changing the placement again. I'm now bringing it to the numerator of my fraction. And I can put that placeholder of 1 on the bottom of my fraction, but I don't necessarily need it on the bottom. I always need it on the top if I'm moving, but I don't necessarily need it on the bottom. Okay, does that make sense? Yeah, okay. So if I had x to the negative 4th, that would become 1 over x to the positive 4th power. Can we see? Do we need me to zoom in? Okay. Okay. What if I had 2 over x x squared y to the negative third power?
X squared y to the third power over 2.
We don't want to necessarily flip the whole fraction. We just want to move the one term that has that negative exponent. So what do you think, Kira? Yeah, so it'd be 2y to the third over x squared. So anytime we see a negative exponent, we're always going to move it, like move only the term that has that negative exponent. Okay? Does anyone remember what anything raised to the 0 power is equal to? Not 0, it's 1. Okay? Anything raised to the power of 0 is just 1. So if I had some crazy number like 5,280, and I have that all raised to the 0 power, it's just going to be 1. Okay? Could be x to the 0. Yeah, that was my example. Could be x to the 0. It could be all of that, 5,280 x squared y to the 5th, all raised to the 0. No matter what, the whole thing becomes 1.
So a lot of properties.
A lot of properties, but we've seen most of them before. All of them before. I promise, we've seen all of them before. We've seen it. Okay? The quotient, right? Quotient of a powers. If I'm dividing and I wanted to simplify it, I have a. What do you think we would do between these exponents?
Combine them.
How do we combine them? We already multiplied them. I don't want to divide them. Subtract.
Oh.
We subtract the exponents there. So if I had k to the third over k to the second, I combine them by taking 3 minus 2 as my exponent, and I just have k to the first power, or just k, right? Anything to the first power is just itself.
Can you leave like the placeholder at the top, Miss I, if you really wanted to?
Where are you on? Like this one? Or where?
Not placeholder. The 1.
Right here?
Yeah.
Oh, yeah, you can keep that there if you need to. Yeah, you can keep the 1 there if you need it to remind yourself. Okay? Last property is power of a quotient. Just like up here where we had said that this exponent needs to be distributed to every term inside your parentheses, the same goes here. It needs to be given to every term in your numerator and as the exponent on every term in your denominator. So in this case, I'd have a to the mth power over m to the mth power.
Why would there just be double
It just means like this exponent on the outside was m, and it just happened that this base was m. So if you had like 2 and you raised it to the exponent of 2, you'd have 2 like squared. It's just like the same number. Okay, so in this example here, I have 6x over y all squared. This exponent is given to every term in the numerator. So both the 6 and the x receive that exponent of 2. And it's given to every term in the denominator. So I get y squared on the bottom. The most I can do, again, because this is a pretty small base with a pretty small number, is I know 6 squared is 6 times 6 to give me 36x squared over y squared.
It's 6x squared and then y over 8.
Where this?
Yeah.
No, I put arrows. There's an arrow going to the 6, an arrow going to the x, and an arrow going to the y. So 6 squared, x squared over y squared. Okay. Questions?
No.
We're just going to practice applying these properties. Practice simplifying exponential expressions. Just trying like to get things into its simplest form. Okay? Am I okay to move down?
Sure.
Okay, so on question 1, it says evaluate the expression. Letter A, you have negative 3 squared times 5 to the third power. Okay? I absolutely cannot multiply the -3 times 5 and then apply the exponent. They are two different bases. Okay. Exactly. We're distributing this exponent into our parentheses. So this -3 now has an exponent of 6 because we multiply. And the 5 now has the exponent of 3. Okay. We're going to actually plug this into our calculator. And something that's different than what we had been talking about is before, when I had the negative numbers, normally they were in parentheses. I had to take the negative into consideration. This question does not want you to take the negative into consideration in your calculator. So you're going to plug in no parentheses. You're just going to put -3, and you're going to use that little upwards arrow, that little, like, I don't know, it points up. It looks like this. Just looks like this on your calculator. And you're going to enter in the 6.
I don't see that.
I have it right above my division symbol.
So we're not putting a -3. Oh, yeah.
You would enter it in exactly like this. It would be -3, this symbol, and then a 6. We're just not putting any parentheses around it. Hello? Yeah, -729.
Wait, Miss A, so you put it in as negative.
This is exactly how you type it without any parentheses.
I got like 90.
Where'd you get 6 from?
Retype it.
Oh.
No, I also got the same thing.
Let me see.
Oh my god, Colin is so loud. What table is that? Colin.
Oh wait, you were talking just for the 3. Okay.
Yeah,
I thought you were
okay.
talking
Yeah, no,
about
sorry, just the 3.
My bad.
Okay? Yep.
Yeah.
So, that's what I get with just the -3 raised to the 6th. Nope, I haven't moved on yet.
No, I know, but you only do it for one and then you do it to the next one.
Yeah, and then I'm going to plug into the calculator this. 5 with my up arrow, 3. Right? So 5 raised to the 3rd power is 125. Okay? Now that I've gotten rid of all of my exponents, this is the step where I'm now allowed to multiply. You can't have any exponents before you multiply numbers. So I'm going to multiply -729 times 125. Good. We get -91,125.
Oh, this isn't too bad.
No, that's not bad.
I thought it would be worse.
Okay. What do you think we would do on B? What would our first step be on B?
Distribute to the 4.
Yeah, we can distribute to the 4 like this exponent. We need to distribute to the bottom as well. So what are we doing between these exponents? Multiplying. So I have 1 to the -8 over 3 to the -4. Before I plug in, I do not want to plug in negative exponents into my calculator. I only ever want to work with positive. So how do I make this 1 to the -8 become a positive exponent? Put it in the denominator. How do I put this 3 to the -4 as a positive? Bring it up. You're basically flipping your whole fraction because both terms were both negative exponents. Okay? Now we can plug into our calculator. 3 to the 4th power, right? Or 3.
81.
Yep, we get 81. 1 to any power. As long as the 1 is positive, 1 to any power is always 1 because you're doing 1 times 1 times 1 times 1 and so on. Do you need that 1 on the bottom?
No.
So you can just leave it as 81.
Now this.
Okay. On question 2. Says a Federal Reserve gold bar weighs 400. I don't really know if that's supposed to say troy ounces. I don't know what it is, but it's ounces. What is the weight of 250,000 of these gold bars? I don't really feel like multiplying 400 by 250,000. Have we seen scientific notation before? Right? 400 would be 4 times what? 10 to the second, right? Because you'd go over 2 decimal places. So 400 is 4 times 10 to the second power. I have to multiply that by 250,000. How do I write 250,000 in scientific notation, right? It has to be 2.5 times, it would be 10 to the fifth because you got to go over 1, 2, 3, 4, 5 spaces. So 10 to the fifth power. Okay. I'm going to multiply what I can. Okay. The first thing I notice is that these are the same bases. So if I have 10 to the second times 10 to the fifth, how do I combine that? What do I do to my exponents? Add them. So we get 10 to the seventh. I'm also going to multiply these two numbers because even though they're not the same base, there's no exponents on them. So I can just multiply 4 times 2.5. That's actually going to give me 10. So I have 10 times 10 to the seventh power. Can I combine those? Aren't those the same base? These are the same base, right? They're both 10s. What's the exponent on this first 10? 1. So I can add exponents to combine them if I'm multiplying, right? So if I wrote this off to the side, 10 to the second times 10 to the fifth, you add your exponents. But there's no exponents. These are just regular numbers. So I don't have to worry about adding them because I'm multiplying this whole thing. They're not exponents.
Would you write, so instead of writing like the big number, would you just do another scientific number? Or would you write out that big number?
Hold on, I'll get there. What was your last question? Right here?
Down below.
Right here? To remind ourselves that this is still the same base here, that I can now add these exponents together. Right? No? I lost you. All I wanted to do is from here, because I got 10 when I multiplied 4.25, that ended up being the same base as this because it's also 10. So I just want to combine one step further. And by putting the 1 here, it reminds me that I have to add the exponents to get 10 to the 8th.
When you multiply on the side, how do you get 10 to the 7?
Adding the 5.
You add your exponents.
No.
But go back to our properties up here. You have to add them if you're multiplying, like right here. Okay. Let's do another example of that. Okay, I have another example lined up. Well, I'm sorry. So going back to that, you can write it as 10 to the 8th ounces or 10 to the 8th.
So you don't do the 10 and the 7?
What 10 and 7?
10.
This?
No.
Well, I added the exponents to get 10 to the 8th.
Oh, so you didn't have to write that big number.
Yeah, you don't have to. You can keep it as 10 to the 8th. I give you another 0. Okay. If I had 3,000 times 5,400,000 and I wanted to solve this, put each of those numbers into scientific notation.
Oh, can you write this down?
Yeah, write this down. Yeah, I'm making up another problem because I feel like this one got confusing because we ended up with another 10. So I want to go over something when we don't have that. Okay. 3,000 written as scientific notation is 3 times 10 to the third. 1, 2, 3, right? So 10 to the third.
So let's see.
5,400,000 is, we have to write it as 5.4 times 10, and then we count 3, 4, 5, 6. Okay? I'm going to do what I did above. I'm going to multiply the tens, right? I can multiply 10 to the third times 10 to the sixth, and according to our property, we add the exponents to get 10 to the ninth. I can also multiply 3 times 5.4, and when I multiply those, I get 16.2 times 10 to the ninth when I multiply these, my 3 and my 5.4. So I get 16.2 times 10 to the ninth. Is that in correct scientific notation? No, right? I got to move one more over and say 1.62 times 10 to the 10th because I just moved the decimal over one more time. Okay. So we're using our properties to help us when we have to multiply in scientific notation, because first off, scientific notation gets a little bit more simple here.
So the other number
This is 5.4, yeah.
the other number always has one exponent and you don't see it. That's what I don't understand. The one exponent.
We didn't have it in this case because we didn't have the same base.
Yeah.
Because this is an inappropriate scientific notation. Remember, scientific notation has to have 1 point something, right? So it's you have one number before your decimal, right? Do we know that rule? Yeah, there has to be one number before your decimal. You don't want two. So you move it over one more time to put it in the correct scientific notation. And because you moved your decimal point one more time, you have to add an extra 1 to your exponent. That goes along with like scientific notation. That rule isn't like an exponent rule, that's your scientific notation rule. Yeah? Okay. You guys try doing A, B, and C. Okay? Try your best and we'll go over them.
Listen, how would you plug in N6 and N3?
You can't. You only plug it into your calculator if you have a numerical base. Yeah.
So I just leave it?
Mhm.
Oh my god. Missy, I don't know how to do A, and I'm confused on.
Yeah, I'm waiting on your call. I don't know.
Wait, Miss A.
Mm-hmm.
When I combine 5 and -2, or add them,
On C. They're two different bases.
so you can't do anything.
The only thing you want to do on C is try to make this become a positive
Oh, so I
exponent.
have to bring it down to the bottom.
We need another minute. You guys want to go over them? We ready? Okay. On A, all three of these terms have the same base. It's all y, right? This is really like we're multiplying them. So what do we do to all of our exponents? We add them, right? We just add them together. So 2 plus -3 is -1. -1 plus 8 is +7. That's my final answer on A. We just add the exponents.
So why is that?
Okay. On B, what do we have to do? Good. Distribute that exponent. Give it to the m and give it to the n. So I get m to the -3rd. What is n going to be raised to? +6, because we're multiplying -2 times -3. And my final answer, I don't want any negative exponents. So how do I make m to the -3 become positive? Bring it to the bottom. So I have m to the 3rd, n to the 6th, but it's on the bottom of my fraction. I got to have my placeholder of 1 up top. So I have 1 over m to the 3rd, n to the 6th. And I can't combine those because those are two different bases. Okay? On C, I have x to the -2nd, y to the 5th, z to the over z to the 3rd. The only thing I see is that I have a negative exponent, which means what do I have to do with it? Move it to the bottom. And I'm only moving the x to the bottom because that's the only term that has the negative exponent.
Before the other term or after? Does it matter?
Like if I wrote it this way or I wrote it this way?
Yeah.
No, that doesn't matter. I like to go in alphabetical order. That's my only rhyme and reason to it. Okay. I'm almost positive that your packet's printed out of order. So question 4 is actually on the back of your packet. Okay, so flip to the back of your packet and then we'll go back into it. So the back page should have question 4 on it. Well, I'm going to go back to that extension problem. Okay. Question 4 says, what is the simplified form of all of this? Okay. There is not one correct path that we can follow to do this. There's a couple of different things. What do you think, Maddox? Yeah. Okay. There's a couple of different things we can do. We can first simplify everything in the parentheses and then distribute the 3. Or we can distribute the 3 and then simplify. You want to distribute the 3?
Yeah, I thought that was good.
Okay. If we distribute the 3, you have to remember that every single term in this parentheses is getting this exponent. So 2 terms on the top and all 3 terms on the bottom. So I get, on the top, I get x to the what? 6th, y to the -3rd, 2 to the, 2 to the 3rd, x to the
What?
9th,
Oh.
y to the 6th. Okay?
Can you put them together now?
So now we can try putting them together. Okay?
Well, wait, Miss A, didn't you take y, the -3, and put it to the 6, and then just take out the y?
Yeah. So the first thing we see is this has a negative exponent. So I need to bring it to the bottom. So I have x to the 6th. I'm going to write out every single step so we know what we're seeing. But I have x to the 6th over 2 to the 3rd, x to the 9th, y to the 6th, and I just brought down y to the 3rd. We can now combine these. Right? So I'll get y to the 9th on the bottom. What about x to the 6th over x to the 9th? What do I have to do to those exponents to combine them? What is my front page? If I had a fraction where I had one on the top, one on the bottom, what do I have to do to those exponents? Subtract them. So 6 minus 9 is -3. Okay? If you take away the negative and you just find the difference, right? The difference between these two exponents is 3. Where are there more x's, on the top or on the bottom? So the x to the third goes on the bottom, right? It's like if I had x to the 6th, there's this many x's.
Wait, X.
I'm working on the x's right now.
So that means 2 to the third goes to the top, right?
1.
Okay? This is x to the 6th over x to the 9th. So when you're subtracting, you're really canceling out all these pairs. X to the third is staying on the bottom there. Okay? So I took care of my y's. I just took care of these x's. I'm not going to move the 2 to the third.
So then 1 goes to the top.
So now I have to have a 1 as my placeholder. The last thing I would say, 2 to the third is what? 8. So I'm going to put 1 over 8 x to the third y to the 9th, right? 2 to the third is not 6 because I'm not doing 2 times 3. I'm doing 2 times 2, which is 4, times 2 again to get 8. Okay, so this would be the simplified version of this mess right here.
Right.
Okay?
There's a lot.
Yeah, it's a lot. It's just practicing properties. Okay?
Not really that much.
I also wrote out every single step. You guys should probably do it in like 2 steps. But I was just showing you exactly what I was doing. Okay? On question 5, it says the radius of Jupiter is about 11 times greater than the radius of Earth. How many times greater is Jupiter's volume than Earth's volume? So first off, I need to know the volume of a sphere. I need that formula. That formula is the volume, is equal to 4/3 pi r to the third. This is how you find the volume of a sphere, right? Sphere, like a planet, Jupiter and Earth,
We learned this last year, something like that.
probably.
Sam, did we do this with Anthony?
Okay. It says the radius of Jupiter is 11 times greater than the radius of Earth. So let's call the radius of Earth r. How would I represent the radius of Jupiter?
J.
No. In regards to r.
11.
11r, right? 11 times r.
Wow, you would think it would be J. You're striking, right?
So, if I find the volume of Earth, it's just this formula here, right? It's 4/3 pi r cubed because the radius of Earth is just r. If I find the radius of Jupiter, I would take 4/3 times pi, but my entire radius is raised to the third power. And now my radius is 11r. So I'm raising that entire thing to the third power. Okay? I have to simplify this, which means I'm going to bring the 3 to become the exponent on the 11 and the exponent on the r. Okay? Just going to show you, if I bring the 11 to the third power out to the front, both of these equations have this pi r cubed. Okay? These are 2 numerical values that I can actually go through and combine. So I'm going to plug into my calculator 11 to the third power, right? I'm going to do 11 with the arrow 3. And what do I get when I have that?
1,331.
Yeah, 1,331. Okay. How do I multiply that against 4/3? What is 1,331 as a fraction? It's over what? 1. When we multiply fractions, we do not need common denominators. We can just multiply across the top and the bottom. So what's 4 times 1,331? Good. 5,324. Over 3 times 1, which is 3. Okay, so look at our final volumes. This was the volume of Earth. This was the volume of Jupiter. This one, this original one. Didn't have to do anything because we're taking the radius as is. Okay, technically, this is our final answer here, but our question is asking how many times greater is Jupiter's volume than Earth's volume? It's right here, right? Because this stayed consistent in my Earth's formula. These stayed consistent in my Earth's formula. So Jupiter's volume is 1,331 times greater.
It's not confusing at all.
Than Earth's volume. Oops. Okay, so we just took the fact that Jupiter's volume's Jupiter's radius is 11 times bigger, but it really affects the entire volume of the planet at a scale of 1,331 because it's 11 to the third power. Okay. Questions?
Are we done?
No.
Oh.
We literally have one more. Stop complaining.
And then we're done?
On the extension.
We don't have any.
No, I told you guys. I copied the second page wrong. The extension came up first before question 4 and 5. It's just flip. Okay? This question says, if you double the length of one of the sides of a cube, will the volume of the cube also double? If not, by what factor will it increase? So, draw a cube.
Oh my god. Welcome to our class.
Square. Square. And then do like little diagonal lines coming out of these 3 and then connect them. Square. Diagonal. 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 Connect.
Promise,
It's like
it's actually
witchcraft.
good. I just look like that. Sometimes looking like it.
All right, maybe we need to practice drawing cubes. Okay, if I double the length of the sides on the cube, we want to know how the volume will be affected. So, actually, let me erase this cube. I'll make it bigger.
Oh, we needed that thing?
Okay, say this cube had a side length of x. If I'm doubling the side length, this cube has a side length of 2x. How do I find the volume of a cube? Anyone remember?
Nope. S squared.
Lex, you just said it.
Oh.
Length times width times height, right? On a cube, everything is the same, right? X is your length, it's your width, and it's your height. So in this case, the volume is your side length cubed, right? Because it's the same for your length, your width, and your height. So the volume of my original cube is x to the third power. The volume of my larger cube is I'm taking that side length and I'm raising that whole piece to the third power, which means I have to distribute the exponent into the parentheses. I get 2 to the third times x to the third. What's 2 to the third?
8.
So how many times bigger is this volume than this volume? It's 8 times bigger. Okay. Now we're done.
Thank God. Well, we got booked,
No.
don't we?
No.
Missy! You're
Oh,
joking me
you're
right
fine.
now.
Why can't we do like a packet?
Yeah. Can you print something out and we'll just do a packet? Or coloring for extra credit?
Sorry.
Okay, your homework tonight.
Killing me.
Page 91. Numbers 3 through
It's gonna be like the
33, do odds and
No, the multiples of it. I've never heard of people like teachers do
Oh,
multiples of
wow.
Like it's either odds.
How did I know?
Multiples are
I can give you the odds, but it's a lot more problems than this. This is cutting it down for you.
So how many columns are
Can I see my test from yesterday? And see what I got wrong?
What was your question? I'm not paying attention to what you're saying.
The test from yesterday, can I see what I got wrong?
Yeah. Give me a second to upload homework and everything. Okay. So this is your homework for tonight. I'm gonna post this up on Google Classroom in a second.
While you're doing that, can you bring my test?
Hold on.